Hey, hi, hello everyone. Very good morning, good afternoon, and good evening. Welcome to the channel Mind Yantra Solutions. In previous session, we discussed about what is an application, the types of applications, and the different components available in a application. Right? In today's session, we'll try to discuss what are the fundamental data structures available in a programming language. Right? So actually, fundamental data structures are like a small kind of memory chunks or like memory units which are used to store the data and the programming execution result. For example, I have a piece of code, I'm trying to execute it. So my programming language will return some data as an output. I want to store them. So in that case, the data will be stored within fundamental data structures. Okay. And these fundamental data structures are categorized into three types. They are stack, queue, and heap. So the stack, queue, and heap are the part of random access memory. Okay. So which is a kind of physical device. And I'm not going to touch about what is meant by RAM, what is meant by ROM. So now we will be discussing about only these fundamental data structures which are used to organize the data which is coming as a part of programming execution result. Okay, so let's start with stack. Stack is a kind of vertical shaped data structure, so which is open only on the top side. So if you want to insert any data, take out any data, these operations should take place only on the top. Okay, so now I want to insert an element called 1. Okay, so the insertion process is known as push technically. So now when I'm pushing the element 1, it will go and stay at the bottom. Now I want to insert one more element, that is 2. 2 will lies on top of 1, and same as 3. 3 will stays on top of 2, right? Now the insertion process is over. Now I want to take out the data from a stack. So the process of taking out the data is known as pop. When I'm going to perform pop operation, whichever the element is available near to the top, okay, technically whichever the elements you have inserted at the last, that will be taken out first. In this case, 3 will be taken out first and then 2. So technically, the stack will work based on a principle called last in, first out. The element whichever is inserted at the last can be taken out from the stack first. So that's why we are calling it as stack follows LIFO principle, last in, first out. Okay, so now let's talk about queue. Queue is a kind of horizontal data structure which is open on the both the sides. It will be open on the left hand side as well as right hand side. Now, if I want to insert an element, the process of insertion will be considered like Enqueue. Let's say I'm going to insert 1, so that will be moved towards the right. And then if I'm inserting element 2, so that will stays left adjacent to the 1, and then 3 will be inserted left adjacent to the 2. Okay, so now I want to take out the data. The data can be taken out in the opposite direction, let's say right hand side. So this process of taking out is known as Dequeue technically. So whenever I perform Dequeue operation, whichever the element inserted first, that will be taken out. So here 1 will be taken out of the queue first. So technically we can say that whichever the element inserted first, that will be taken out first. So we can say queue follows a principle called FIFO, first in, first out. Okay, so here stack and queue both are like ordered data structures. Okay, we can insert the data in a specific order like 1, 2, 3. Okay, have 1, 2, 3 in a horizontal or vertical, right? They will be ordered. You can insert any element, but they will be positioned in a particular order. Now let's talk about the other fundamental data structure, that is heap. Okay, it will not look like horizontal and it will not look like vertical. It is a kind of circular memory unit or data structure, it's just an assumption only. and where the data will be inserted in an unordered format. That means in a random manner, right? Unlike stack and queue, the data will be stored inside the heap, but each data or each value will be mapped with a specific reference point called key. You can see here value 1 is mapped with a key called key 1. Suppose I am going to insert another value that is 2, that will be mapped with key 2. Okay, this is a reference point. Like this, whatever the values or data we are going to keep it inside the heap will be having a reference point called key. It will be very easy to access the data from a heap compared to stack and queue. Okay, for stack and queue, the time complexity of taking the data will be O of n or O of 1 in the best case. But in the case of heap, the time complexity of accessing the data will be O of n log n. Okay, so it will be very faster compared to stack and queue, and it will be easy to pick it up. It's just something like if you want to take out a green tea packet from the box, what you will do? You will simply take that token or a paper sheet and then take it out easily. In the same way, that token will be nothing but key here. With the help of key, you can access a value easily and very quickly. Okay, this is all about heap. So we have covered about the 3 fundamental data structures today: stack, queue, and heap. I'm just stopping it here. Let me know if you have any questions or suggestions. Put in the comment below. And that's all for the day. Signing off. Thank you.